resisting blast. In addition, this is a 3-ply CLT panel, so that's the smallest they've got. And these are the connections that were exposed to blast in the arena tests, both a prefab steel angle with screws and then self-drilling screws up at a diagonal. And this is how they did in the post-test. The ones with the steel angle performed very well. They remained intact even though the panel was overloaded, so they performed well. These, not so great. These were also the steel angles, but the wrong screws were installed in these. They installed 1.5 inches long instead of 3.5 inches long. So as a result, the failure was in withdrawal and the panel was overloaded. And then the self-drilling simple screw connections failed when the panel was overloaded as well. So these responses gave us some good data regarding designing a proper connection, and you know, the steel angles with the 3.5-inch screws did great. Moving on to ballistics. These ballistic tests were performed at Georgia Tech in 2019, and you know, long story short, they determined that ordinary CLT is not great at stopping ballistic threats. So as a result, when you have a ballistic requirement and want to use CLT, you may need an additional barrier or an alternative layup. Other options are that we're performing tests now. In 2020, actually, we performed some tests on 18-inch square tiles that had varying projectiles, and we used multiple CLT layups, including hardwoods. There were some panels that had steel plates embedded in them, laminated into the CLT panel, and some had steel mesh embedded into them. And it was found that the panels with 2 8-inch steel plates performed really well. So that's potentially a product that we're looking at moving forward. We're continuing with some testing on these reinforced CLT panels, they're called, with the steel plates embedded. So right now, we're actually just recently, they were load tested to see if the bond would form and if the steel would add strength and ductility. And this is a video I'm going to try and play here. So this is the load test being performed, and you'll see that even after shear failure, the steel plates really added a lot of ductility to them, and a lot of load was able to be added on even after the fact. So this is a product that testing is still ongoing. The idea behind it is perhaps it might be able to be an off-the-shelf product in the future if you've got a really heavily loaded structure or you've got ballistics requirements, that kind of thing. And then forced entry tests were also performed. This was using a 7-ply panel. This panel resisted the attack for over 40 minutes. To achieve 60-minute, you might be able to do more plies or harder or denser wood, that kind of thing. However, I think I've heard this correctly. You guys might be able to tell me if I'm right or wrong, but I think the forced entry requirements have changed since then. So the CLT may perform a little bit better. I think the tools or something have altered requirements. So testing is still ongoing, is the short story. In addition to what I've talked about here, OBO is doing their own mass timber study, ongoing currently on blast, forced entry, progressive collapse, all of that. And they're planning to incorporate CLT into their diplomatic buildings. And then additional reinforced CLT testing. We're doing quasi-static bending, which is the one you just saw. And next is blast testing of the full-size panels, including panels with openings. So that's the testing that's coming up here soon. As well, they're looking at some moisture transport studies to make sure that moisture is not going to be a problem in between those 2 steel plates, moisture in the wood. Okay, and here's a list of some of the design aids that are available. I'm sure folks on this call are very familiar with these. In addition to the PDC TR 1802, we've published a solutions paper called Analysis Guidance for CLT Construction and Exposed to Air Blast Loading, and it just provides an overview of the PDC TR 1802 to help engineers understand and navigate the design process if they're not familiar. And then I mentioned this earlier, we're also worked with Aspect Structural Engineers on a progressive collapse paper with mass timber. This actually hasn't been published yet, it's still in editing. And the purpose was not to be a design standard or a guide to meet a particular standard, as there really isn't one yet, but instead it's meant to emphasize the steps that can be taken to create a mass timber structure that's got more redundancy, more ductility, better structural integrity by using common approaches and other progressive collapse design materials. So KNC is working with the Army Corps of Engineers to update the UFC progressive collapse document to include mass timber. And this project is a little older now. I don't know if you guys know of this one yet or not, but one of the interesting things about it is that it's a hotel on a military base, and it was designed and constructed in 2015, meaning it needed to meet the higher anti-terrorism and force protection standards at that time. And it was constructed using CLT walls, floor, and roof. So in addition to meeting the protective requirements, it was completed 37% faster and built with 44% fewer person hours than similar hotels that they had done in the past. This was done by Lend-Lease. In fact, it was done with an 11-person crew, 3 experienced carpenters and 8 laborers. It worked out great because at the time, labor was in very short supply, so the laborers were formerly unemployed veterans who were trained on the job site. And then, of course, sustainability. This was the Candlewood Suites sustainability report. So definitely something to a perk. So the summary is that, at least of the blast space, is that mass timber is capable of resisting blast loading. The two-way action of the CLT helps distribute the load and minimize the peak response. Connections for the mass timber systems can be designed to exhibit a ductile response. Ballistic requirements need to be addressed in some other way, at least for now, and it can be, the steel plates we discussed or some other manner. And the forced entry requirements of 40 minutes have been determined and 60 minutes is feasible, and testing is still ongoing. And just as I close, I wanted to just bring up WIN, which is a program of Woodworks, worksinnovationnetwork.org. And it's an online community of mass timber and innovative light frame projects. And the idea is that architects, engineers, and contractors create accounts, upload their bios and their experience. And so what this is handy to do is not only for them to kind of advertise and show their background in mass timber, but if you're looking for, a project and you want to glean some information, or if you're looking for a team that's really familiar with mass timber and has done mass timber before, you can browse by map. It brings up all the projects. You can zoom in and it'll bring up the projects, and then you can hover and click. You've got filters there, and it's kind of like shopping on Amazon. You just click through what you want. So if you want something in the Pacific Northwest with 200,000 square feet or more, brings up just these few. And then you can hover over any of them, and that one in particular is Adidas, North American headquarters. So it's a great little tool if you're looking for a good team. In addition, you can go to the Adidas, in this case, page, and it's got the team on there. It's got information about the building and pictures, and then you can even click through, and there's contacts there if you want to contact somebody on the team. So a lot of designers come to us asking about, they want to find a team that's familiar with mass timber, their contractor or their engineer or what have you is not familiar and isn't interested, et cetera. And then lastly, I think termites was mentioned as a topic of interest, which I didn't get to incorporate that really here, but I did want to mention that we've got an expert tip on our website that goes into detail about strategies to design and construct wood frame buildings for termite protection. And that is it for me, except for the questions, of course.